Tapping off the line side of the main fuse is a violation of the National Electrical Code, or NEC. The service entrance conductors, often referred to as feeders, must be protected by the main disconnect device, whether it's a fuse or a breaker. Now, tapping off the load side of the main fuse is permitted, as long as the tap conductors are protected by the correct of a current device. In the scenario presented, a 40 amp breaker would serve this purpose. The use of a hold-down kit is an acceptable method for securing the tap conductors. It's also possible to replace a fuse box with a breaker box without disturbing the meter socket and mass assembly. Here's a breakdown of the process. Firstly, disconnect the power. Turn off the main breaker or pull the main fuse before starting any electrical work. Secondly, remove the old fuse box. Disconnect the wires from the fuse box and carefully remove it from the wall. Thirdly, install the new breaker box. Mount the new breaker box in the same location. Connect the service entrance conductors to the main breaker or lugs in the new box. Fourthly, connect the other circuits. Connect the existing circuit wires to the appropriate breakers in the new box. It's crucial to remember several additional points. The subpanel should ideally be located within 6 feet of the main panel, and the circuit conductors must be sized appropriately for the load, in this case, a 3-ton air conditioning unit. If the main service is rated for 60 amps, the subpanel feeder should not exceed 40 amps. For safety and compliance with electrical codes, it is always recommended to hire a qualified electrician to perform electrical work. Now let's delve into some further details regarding these procedures and considerations. When tapping off the load side of the main fuse, ensure that the tap conductors are of adequate size to handle the intended load. Refer to the NEC table 310.16 for conductor ampacity based on insulation type and temperature rating. It's also essential to maintain proper grounding and bonding throughout the electrical system. This includes connecting the grounding electrode conductor to the neutral busbar in the main panel and bonding the subpanel enclosure to the grounding system. Regarding the replacement of the fuse box with a breaker box, consider the following steps in more detail. Begin by carefully inspecting the existing wiring for any signs of damage or deterioration. Replace any damaged wires before proceeding with the installation. When connecting the service entrance conductors to the new breaker box, ensure that the connections are tight and secure. Use an appropriately sized torque wrench to tighten the terminals according to the manufacturer's specifications. Also, make sure to properly label each circuit breaker in the new box to indicate the circuits they control. This will make it easier to identify and troubleshoot any electrical problems in the future. When connecting the existing circuit wires to the breakers, use wire connectors that are rated for the size and type of wire being used. Tighten the wire connectors securely to ensure a reliable connection. Before energizing the new breaker box, double-check all connections and ensure that everything is properly installed and grounded. Use a multimeter to verify that there are no shorts or ground faults in the wiring. Once you're confident that everything is safe and correct, turn on the main breaker and test each circuit to ensure that it is working properly. If you encounter any problems, immediately turn off the power and troubleshoot the issue before proceeding further. Remember, electrical work can be dangerous if not performed correctly. If you're not comfortable working with electricity, it's always best to hire a qualified electrician to do the job for you. Let's also consider some additional factors related to the subpanel installation. The size of the subpanel should be determined by the number of circuits that will be connected to it and the total load that it will be carrying. Choose a subpanel that has enough spaces for all of the required breakers. When running the feeder conductors from the main panel to the subpanel, use the appropriate size and type of wire for the distance and load. Refer to the NEC table 310.16 for conductor ampacity and voltage drop calculations. Install a separate grounding electrode conductor from the subpanel to a grounding electrode, such as a ground rod or water pipe. This will help to ensure that the subpanel is properly grounded and bonded. The grounding electrode conductor should be sized according to the NEC table 250.66. In addition to the grounding electrode conductor, also install a bonding jumper from the subpanel enclosure to the neutral busbar. This will help to equalize the voltage potential between the enclosure and the neutral conductor. The bonding jumper should be sized according to the NEC Table 250.102. When installing the breakers in the subpanel, make sure to use the correct type and size of breaker for each circuit. Overcurrent protection devices are crucial for safety. The breakers should be properly labeled to indicate the circuits they control. Finally, after completing the subpanel installation, have a qualified electrician inspect the work to ensure that it is safe and code compliant. Let's further elaborate on the NEC requirements related to tapping service entrance conductors. According to the NEC Section 230.46, splices shall be made as near as practicable to the service head, service equipment, or tapping devices. This means that the tap connection should be located as close as possible to the point where the service entrance conductors enter the building or connect to the service equipment. The NEC also requires that the tap conductors be protected from physical damage. This can be achieved by installing the tap conductors in conduit or other approved raceway. Furthermore, the tap conductors must be sized according to the NEC Table 310.16, based on the ampacity of the overcurrent device protecting them. In the scenario described, the tap conductors are protected by a 40 amp breaker, so they must have an ampacity of at least 40 amps. The NEC also addresses the issue of overcurrent protection for tap conductors. According to the NEC Section 240.21b, tap conductors shall be protected against overcurrent in accordance with one of the following methods. Firstly, tap conductors not over 10 feet long. The ampacity of the tap conductor shall not be less than the calculated load and shall not be less than the rating of the overcurrent device at the termination of the tap conductors. Secondly, tap conductors not over 25 feet long. The ampacity of the tap conductor shall not be less than 1/3 of the rating of the overcurrent device protecting the feeder or branch circuit conductors from which they are tapped. The tap conductors shall terminate in a single circuit breaker or set of fuses that will limit the load to the ampacity of the tap conductors. Thirdly, tap conductors supplying a transformer. The tap conductors shall have an ampacity of not less than 1/3 of the rating of the overcurrent device protecting the feeder conductors. The tap conductors shall terminate in a single circuit breaker or set of fuses that will limit the load to the ampacity of the tap conductors. In addition to these requirements, the NEC also specifies that the tap conductors shall be installed in a neat and workmanlike manner. This means that the conductors should be properly supported and secured, and that all connections should be made with approved connectors. Let's also discuss the requirements for replacing a fuse box with a breaker box. According to the NEC Section 408.4, all panel boards shall be durably marked in a manner that will allow each circuit breaker or switch to be conveniently and legibly identified as to its clear, evident, and specific purpose. This means that the new breaker box must have a directory that clearly identifies the circuits that are controlled by each breaker. The NEC also requires that the new breaker box be properly grounded and bonded. This includes connecting the grounding electrodes conductor to the neutral busbar and bonding the enclosure to the grounding system. Furthermore, the NEC specifies that the new breaker box must be installed in a location that is readily accessible. This means that the box should not be obstructed by furniture, appliances, or other objects. In addition to these requirements, the NEC also addresses the issue of working clearances around electrical equipment. According to the NEC Section 110.26, sufficient access and working space shall be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. This means that there must be enough space around the new breaker box to allow for safe and easy access for inspection, maintenance, and repair. The specific working clearances required depend on the voltage of the equipment and the presence of any exposed live parts. Finally, it's important to remember that any electrical work should be performed in accordance with all applicable codes and regulations. This includes the National Electrical Code, as well as any local codes or ordinances that may be in effect. If you have any questions about the code requirements, it's always best to consult with a qualified electrician or electrical inspector. Now let's discuss the specific situation of installing a subpanel for a 3-ton air conditioning unit. The first step is to determine the load requirements of the air conditioning unit. This information can be found on the unit's nameplate, which will list the voltage, amperage, and other electrical characteristics. Once you know the load requirements, you can select the appropriate size of breaker and wiring for the subpanel. The breaker should be sized to protect the wiring from overcurrent, and the wiring should be sized to carry the load without overheating. According to the NEC section 440.22a, the branch circuit conductor supplying a hermetic refrigerant motor compressor shall have an ampacity not less than 125% of the motor compressor rated load current or branch circuit selection current, whichever is greater. This means that the wiring for the air conditioning unit must be sized to carry at least 125% of the unit's rated current. In addition to the wiring and breaker, you will also need to select an appropriate size of subpanel. The subpanel should have enough spaces for the breaker for the air conditioning unit, as well as any other circuits that you may want to add in the future. The subpanel should also be properly grounded and bonded, as described earlier. Once you have selected all of the necessary components, you can begin the installation process. Start by disconnecting the power to the main panel. Then run the wiring from the main panel to the subpanel. Be sure to use the correct size and type of wire, and to follow all applicable codes and regulations. Next, connect the wiring to the breaker in the main panel and to the breaker in the subpanel. Be sure to tighten all connections securely. Finally, connect the wiring from the subpanel to the air conditioning unit. Again, be sure to use the correct size and type of wire, and to follow all applicable codes and regulations. Once you have completed all of the wiring, you can turn the power back on and test the air conditioning unit. If everything is working properly, you have successfully installed a subpanel for your air conditioning unit. Remember, it's always best to consult with a qualified electrician if you have any questions or concerns about electrical work. Electricity can be dangerous, and it's important to take all necessary precautions to ensure your safety. Now let's consider some of the potential hazards associated with electrical work and how to avoid them. One of the most common hazards is electric shock. Electric shock can occur when you come into contact with a live electrical circuit. The severity of the shock depends on the voltage of the circuit, the amount of current flowing through your body, and the duration of the contact. Electric shock can cause a range of injuries from minor burns to cardiac arrest. To avoid electric shock, always disconnect the power before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes to protect yourself from electric shock. Another common hazard is arc flash. Arc flash is a dangerous electrical explosion that can occur when a short circuit occurs in electrical equipment. Arc flash can cause severe burns, blindness, and even death. To avoid arc flash, always wear appropriate personal protective equipment (PPE) when working on electrical equipment. This includes a face shield, safety glasses, hearing protection, and flame-resistant clothing. Another potential hazard is fire. Electrical fires can occur when electrical wiring or equipment overheats. Electrical fires can spread quickly and cause significant damage. To prevent electrical fires, make sure that all electrical wiring and equipment is properly installed and maintained. Do not overload electrical circuits, and do not use damaged or frayed electrical cords. In addition to these hazards, there are also a number of other potential risks associated with electrical work. These include falls, cuts, and other injuries. To minimize these risks, always work in a safe and organized manner. Use appropriate tools and equipment, and follow all safety procedures. If you're not comfortable working with electricity, it's always best to hire a qualified electrician to do the job for you. Electricians have the training and experience to safely and effectively perform electrical work. They also have the necessary tools and equipment to do the job right. Finally, it's important to remember that electrical codes and regulations are constantly evolving. It's important to stay up to date on the latest codes and regulations to ensure that your electrical work is safe and compliant. You can find information on the latest codes and regulations from your local electrical inspector or from the National Electrical Code website.